The object below is a piece of steel with the distance it is equals to 10 centimeter. It consists of the rectangular part A with dimensions 30 centimeter by 10, a triangular part B, and a semicircle cut out C. Fill in the missing information. I only took the last question that says find the polar coordinates of the center of mass for the whole object, since filling in the information is the information that we require in order to answer this last question that requires us to determine the polar coordinates of the center of mass. So there's a diagram that is given there and it is labeled. So I have redrawn the diagram below here. I have redrawn the diagram. So now we'll have to perform the necessary we have to perform the necessary cutouts and then of this object as given. So they say it consists of a rectangular part A with dimensions 30 centimeter by 10. So these dimensions simply means that on this rectangular part, there's a length or there's a side which is 30 centimeter and there's also another side which is what? Which is 10 centimeter. So when we look into the shape and look at the space, this space is the 2D plus D, which is 3D, and then 3 times 10, which is 30. And then when we go up, this is only 10 centimeter since it is the units. Therefore, that means the rectangular part they are referring to is this one, and it is labeled A. And then it also consists of a triangular part D. We only have one triangular part here, which is a right angle triangle at the top here. So this right angle triangle at the top here, it's part B, and then we also have a semicircle which is a cutout. So the semicircle which is a cutout, we can see it's here. So this semicircle which is a cutout, it is labeled C, and then the distances are also given accordingly. So therefore, we have all the information that we require. Let's draw our table to fill in the missing information in order to find the polar coordinates of the whole system. We're gonna draw our shape, and then we have the object A. We also have the object B and the object C. Now we firstly gonna determine their areas. I'll just call it AI. So their areas, so let's start with the first object or the first rectangular part, which is A. So the first rectangular part consists of the length, which is 2D plus D unit. I mean the breadth, which is 2D plus D units, and then the height, which is D units. Therefore, we know that the area of a rectangle is length times breadth. Therefore, this tells us that the area for the shape will be 3D, 2D plus D, which is 3D, and then we multiply this by D. And then from here, we have a right angle triangle, that is the part B. So we know that the area of a right angle triangle is half base times height. So the base of this right angle triangle is only the base of this right angle triangle, it's only D unit, and its height is also D units. Therefore, that means the area here for the right angle triangle will be half D squared. And then for object C, which is a cutout and a semicircle in shape, Its area is going to be pi half pi r squared. That's how we determine the area of a semicircle, half pi r squared. But now we notice that there's a a cutout. It's a there's a semicircle. It's a cutout. So since it is a cutout, it cuts this bigger rectangular shape. Therefore, it already tells us that the area of this cutout of this semicircle needs to be subtracted from where from the area of this rectangular part. So as a result, the area of this semicircle needs to be a negative. Therefore, when we go to our table, that means then our area here will basically be minus 1 over 2 pi, and then radius. The radius of this cutout is going to be d over 2, since its diameter is d units. So we're going to have d over 2. D over 2 and then squared. So that's how we find the areas. So we are done with the first part of the area. So let us just continue and compute what is required. So 3 times d, which is 10 units, times 10, which is going to give us 300 centimeter squared. And then the second one is going to be half into 10 squared. And this is 50 centimeter squared as well. And then minus 1 over 2, shift pi into 10 divided by 2 squared, and this gives us minus 25. This gives us minus 25 over 2 pi centimeter squared. So those are the areas. So now let's continue and find the x and the y center of mass. So take it as if like this table continues here. After the areas, then there comes the x and the center of mass. Okay, it just continues here. Okay, so I will just write it below here. So now we have to determine the x center of mass and as well as the y center of mass. We have object A, and then we have object B as well, the object C. So let's go ahead and find those x and y intercepts of the center of mass for each shape. The first shape, which is the rectangular part, both their x and the y, both their x and the y coordinates of the center of mass, we find them by half k. And remember that the distance that the object is located from the origin, both along the x and the y, affects the value of the center of mass. So in this case, the rectangular part starts exactly at the origin. It didn't move any distance from the origin, and it didn't move any distance upwards from the origin. Therefore, this tells us that the x center of mass will simply be 0 plus half of its base. So the base of this rectangular part is 2d plus d, which is 3d. So this is half of 3d. And then each y center of mass will be 0 plus then the half of what is the height of this rectangular part. It's only d units. So those are the x and the y that these are the formulas we're going to use to find the x and the y coordinates of the center of mass for object A. And then for object B, which is a right angle triangle. So let's go back to our sketch. So for object B, which is a right angle triangle, First thing first, we can notice that this right angle triangle along the x, it's located 2D units from the 2D units from the x-axis. Therefore, its center of mass, the coordinate is going to be 2D plus the x coordinate of its center of mass. So for right angle triangle, how we find the x coordinate of the center of mass is 2/3 of its base. So the base, it's only d units. And then its y coordinate of the center of mass. Let's go back again to the diagram. We can see that this shape is located d units away from the origin. Therefore, the y center of mass for the shape will be d plus the y coordinate of the center of mass, which is given by 1/3 of the height. So its height, it's only d units. And then now we move on to the last shape, which is a cutout. So this cutout shape is located 2D. This cutout shape is located, this cutout shape is located 2D plus D units from the origin. So we're gonna have 2D plus D, which is 3D. But in this case, it's going to be minus instead of a plus because this is a cutout, right? It cuts a shape, right? If, for instance, let me say this wasn't a cutout, it was located outside like this, then it would make sense to say 3D plus the x coordinate of for this semicircle. But in this case, it's a cutout, so it's going to be 3D minus the x coordinate of the center of mass, which is given by, so minus, which is given by 4 over 3 pi multiplied by the radius. So the radius of this semicircle is d over 2. And then its y coordinate of for the center of mass, we can see that on the y, it didn't move any distance up or down, so it will simply be 0. It will simply be 0 and then plus the y coordinate of its center of mass, which is simply going to be the radius, right? Because when we speak of for center of mass, we simply talk about the middle condition. So on this semicircle, if I make it more practical, what do we mean by center of mass? We are looking for the coordinates of this point. Okay, so we can notice that for x, when we try to find this coordinate, x, it's somewhere here, right? So it's somewhere here. So since now it is located at least half away of this semicircle, that's why it has to be 4 over 3 pi. But for the y, we can see that it is straightforward that the distance from here to here, it is simply r units. The radius, it's radius units. So therefore, the y coordinate of the center of mass will simply be what? Be d over 2 units. So therefore, we come here, this is 0 plus d over 2 units. So let's go ahead and find 0 plus d over 2 units. So therefore, yeah, these are the equations that we're gonna use to find the what is required. So now let's compute them. Let's compute them so that we can just substitute when we find the center of mass for the whole system. X is the center of mass and then Y center of mass. Now let's compute the first one. The X center of mass is 0 plus 1 over 2 into 3 times 10. Okay, that is going to be 0 plus 1 over 2 and then 3 times 10, which is 15. So we have 15 here, and then the Y is going to be the half of D, which is 10, and that is 5 centimeter. So we have 5 centimeter, and then for B, we have 2 times 10 plus 2 over 3 times 10, and that gives us 80 over 3. And then the corresponding Y is D, which is 10, plus 1 over 3 into D, which is 10. And that is 40 over 3 centimeter. And then now let's move on to the last one, which is C. So there is 3 times 10 minus 4 over 3 pi, and then multiply by D, which is 10, and then divided by 2. And that gives us 27.87 something. So I don't really prefer to write the decimals. Yeah, I prefer to just write them in a fraction form or as a whole number. So what I will do is that I'll just write this whole number as a whole. So we have it's that is 3 times 10, which is 30, and then this is minus 4 over 3 pi multiplied by 10 over 2. So that is going to be 10 divided by 2, which is 5. So that is basically minus 3 minus 4 over 3 pi, and then this is multiplied by 5. So that is going to be 5 times 4, which is 20. So we basically have minus 20 over 3 pi, minus 20 over 3 pi. So that is our y, and then the x will be 0 plus d over 2. So that is 10 divided by 2, which is 5. We're gonna have 5 here. So these are the values. Perfect. Now we have all the information that we need. We can go ahead and find our center of mass, the polar coordinates of the center of mass. So the x center of mass will be given by the area of object A multiplied by the x coordinate of the x coordinate of its center of mass, and then the area of B multiplied by the x coordinate of its center of mass plus the area of C multiplied by the x coordinate of its center of mass, and then divided by the total area. So I'm not gonna write all these values down here. I'll just give the final answer. So let's punch on a calculator. We have all the information. So previously we saw that the area of A is 300. So we're gonna have 300 centimeter cubed. We multiply it by the x coordinate of its center of mass, which is 15, plus the area of B, it's 15, multiplied by the x coordinate of its center of mass, which is 80 divided by 3, and then plus the area of object C, which was found to be minus 25 over 2 shift pi, and then we multiply this by the x coordinate of the center of mass, which is given by 30 minus 20 over 3 pi, and then we divide this by the total area, which is going to be 300 centimeter cubed plus 50 centimeter cubed minus 25 over 2, and then shift pi. Okay, so I just punched everything on the calculator, and I'm getting that the x center of mass for the AC system is 15.225. That is the x center of mass. And then the y center of mass, and then the y center of mass, will be given by the area of part A multiplied by the y coordinate of its center of mass by the area of B by the y coordinate of its center of mass by the area of C plus y coordinate multiplied by y coordinate of its center of mass, and then we divide this by the total area, and then let's see how much do we get. We have we have 300 multiplied by 5, and then the second one we have 50 multiplied by 40 over 3, and then the last one we have minus 25 over 2 pi multiplied by 5. And then this is divided by the total area, which is 300 plus 50 minus 20, 5 over 2 pi. And I'm getting that the y coordinate of the center of mass is 6.34. And then the question required us to find the polar coordinates for the center of mass for the whole system. So those polar coordinates will be, I forgot to include the units. So the units here we have centimeter square, and then here we have centimeter cubed, and then divided by centimeter. So the units will basically be 15.25 centimeter squared. And then even here for the y, it's centimeter squared. Therefore, the polar coordinates are, what is our value of x 15.25? 15.25 and 6.34, all in centimeter squared, and that will be the final answer.